This video covers prediction and how to use the regression equation to make predictions. We're going to start with example 1, which recalls an example we worked in the previous presentation for correlation and regression. The house price data led to the following regression equation: y equals 0.0992x plus 160.194. If you'll remember, the x represented the house size in square feet, and the y represented the cost of the house. We want to predict the price of the home with 2,700 square feet and predict the price of the home with 4,500 square feet. So what we need to remember is that x is the size of the house, and y is the price or the cost of the house. So what we're going to do is, this 2,700 square feet is the size of the house. So in this case, x equals 2,700. So we're going to substitute 2,700 in for x into the equation. So we have y equals 0.0992 times 2,700. So instead of x, we'll replace that with 2,700 plus 160.194. And then we just do the arithmetic. So if you have a calculator, that makes things a bit easy. So let me pull the calculator up here. Okay, we have 0.0992 times 2,700 plus 160.194, and we get 428.034. 428.034. So 428.034, if you'll remember, the cost is in thousands of dollars. So this means that the price of the house is $428,034. Okay. Next, we're going to predict the price of the home with 4,500 square feet. So why don't you pause the video, and when you unpause it, we'll go over the answer. Okay, if you substitute in 4,500 for x, you have 0.0992 times 4,500 plus 160.194, and you get 606.594, which is equivalent to $606,594. Okay, so we're going to move on and talk about interpreting the predicted value of y. So which of those answers do you think will be the better prediction? So let's go back and look. The $428,034 for a home that's 2,700 square feet, or a home that is $606,594 that is 4,500 square feet. So which do you think is the better prediction? So the first one was called an interpolation, because it made a prediction for a data point inside the range of data. So if you go back and look at your notes from the previous presentation, or if you look at the previous PowerPoint and you recall the list of data, 2,700 fell within the range of data values for the size of the house. So because it used a data point that was inside the range, is called interpolation. The second one is called extrapolation. Extrapolation, because it made a prediction for a data point outside the range of data. So this 4,500, that was a bigger number than any of the other houses in the set of data that we were given. I think the highest, if I remember correctly, the highest was 3198 or somewhere around there. That was the biggest house. So 4,500 is definitely outside of that. So that's called extrapolation. So if you predict using a data point inside the range, it's interpolation. If you use a data point outside the range, it's extrapolation. And what we need to know is that interpolations are more reliable than extrapolations. And the reason is because when we calculate that regression equation, it is based off of the data that we're given. And in that data range, we don't know what trends are going to happen once you get outside of that range. It could change. So that's why interpolation is the better and more reliable of the two. Okay, let's look at example 2. The data on students' third test and final exam led to the following equation for the regression line. So we had this set of data points 2, and I believe we found this this regression equation in the correlation and regression presentation. So what final exam score would you predict for a student who scored 60 on the third test? So just to remind you, X is their score on the third test, if you don't remember, and Y is their score on the final. So what final exam score would you predict for a student who scored 60 on the third test? So pause the video, and when we come back, we will go over the answer. Okay, so if you substitute 60 in for the X, because X is the score on the third test, and that's what they made on the third test, and we multiply 4.827 times 60 and then subtract 173.513, we get 116.107, and you might think, that makes no sense. How can you make 116.107 on a test? But if you will remember from the set of data that they gave us in the last presentation, this was out of 200 points. I believe that the third test was out of 80. All right. Next, let's talk about interpreting slope. So, if the x values of two data points differ by 1, their y values will differ by the amount of the slope. So, if the x differs by 1, then the y will differ by the amount of the slope. If the x values of the data points differ by 2, then their y values will differ by 2 times the slope, or twice the slope. And it says etc. So that means if the x values of two data points differ by 3, their y values will differ by 3 times the slope. If the x values of two data points differ by 4, then their y values will differ by 4 times the slope. So if I tell you that two data points differ, the x values of two data points differ by, say, 17, and then you want to know how much the y's will differ. Well, you can plug everything into the equation twice and see what the difference is, or you can just kind of follow this rule and say, well, if the x's differ by 17, then that means that the y's will differ by 17 times the slope. And remember, m represents slope. So two houses different in size by 300 square feet. So remember, the size was your x. So the x differs by 300. How much would you expect their prices to differ? So the prices is the y, or the y's. So it will differ by, what does the x differ by? 300. 300 times the slope. So we need to go back and recall what the slope is. So if you'll recall, this was right up here. This was the equation we found for the house sizes and the cost. It was 0.0992x plus 160. So the slope is this, 0.0992. So to find the difference in the y's, we would multiply 300 times 0.0992. And we get 29.76. And if you'll remember that the y is in thousands, so that would mean that we would expect the two houses to differ in price by $29,760. Okay, example 4, making predictions. At the final exam in a statistics class, the professor asks each student to indicate how many hours he or she studied for the exam. After grading the exam, the professor computes the regression equation for predicting the final exam score from the number of hours studied. The equation is y equals 50 plus 5x, where x is the number of hours studied and y is the score on the final exam. Antoine studied for 6 hours. What do you predict his exam score to be? So pause the video and see if you can determine what that is. Okay, hopefully you did that. 50 plus 5 times 6 hours of study will be 50 plus 30, which is a score of 80. All right, Emma studied for 3 hours longer than Jeremy did. The 3 hours, that's your x. So 3 hours longer than Jeremy did. How much higher do you predict Emma's score to be? So think about it for a moment, pause the video, and see if you can figure out what the answer is, and then we'll go over it. Okay, the difference in the x's from Emma to Jeremy would be 3 hours. That's the difference in the x's. So to determine the difference in the y's, the difference in their scores, we multiply the difference in the x's, which is 3, times the slope of the regression equation, which is 5. So 3 times 5 would be 15, which means Emma's score differs from Jeremy's by 15 points. Okay, we're going to stop the video here, and we're going to pick up with part 2 with interpreting the intercept.